to get you primed up to answer this question, let's first discuss a little bit about the instruction set architecture of a processor. In the instruction set architecture of a processor, instructions are atomic by definition. Or in other words, if you think about reads and writes to memory, which are usually implemented at loads and stores in the instruction set architecture of a processor, those are atomic instructions. And what that means is, during the execution of either a load instruction or a store instruction, or also, as you might think about them, read or write instruction to memory, the processor cannot be interrupted. That's important. That's the definition of an atomic instruction, that the processor is not going to be interrupted during the execution of an instruction. Now, the question that I'm going to ask you to think about is, if I have a multi-threaded program, and in that program there is a processor P1 which is modifying a data structure A, and there is a processor P2 that is waiting for the modification by B1 to be done, and after the modification is done, it wants to use that structure. Fairly natural to think about situations in which you have this kind of a producer-consumer relationship. This guy is the producer of data, this guy is the consumer of data, and the consumer wants to make sure that the producer is done producing it before he starts using it. Quite natural. Now, given that the instruction set architecture is only read and write atomic instructions, the question that I'm going to pose to you is it possible to achieve the programmer's intent that I have embodied in this code snippet here? And the answer is a binary answer, yes or no. And if you answer yes, I would like to see a code snippet that you think would make this particular code snippet work correctly on a multiprocessor.